Alright, Unit 2 is called Differential Equations. and 2.1 is titled First Order Linear Differential Equations. Sounds like a very intimidating topic. It is not. Okay, this should all seem very familiar to you based on all the things you covered last semester in AB. And let's get going. So, a little definition to start. An equation involving a derivative is called a differential equation. That's what a differential equation is. Just an equation that involves a derivative. And one way differential equations are often classified is by the order of the highest derivative involved in the equation. So a first order differential equation would just involve a derivative of like the first order. So a first derivative. I mean, you know how there's first derivatives and second derivatives. You know this. And so that's all this really is. And you might be pleasantly surprised to see that here is a pretty simple example of a differential equation. So just notice that this equation involves the derivative dy dx, a first derivative, over here on the left side. And you probably did something exactly like this last semester when you were given something that you were told was the derivative, and you wanted to like go backwards to identify the original function. So I'm sure there was plenty of times last semester where you went from whatever the derivative was and took it back to the original function. You know, you had f prime and you needed f, or you were given dy dx exactly like this and you needed to figure out, look, y, you know, or you were given the velocity function and you needed to find the position function. How do you do all this? How do we go from dy dx to y? Well, we take the integral, of course. But first, something technical, you know, that you could do is basically multiply the dx to the other side. Okay? So multiply dx to the other side. Essentially, I mean, you're taking the derivative, you're taking the integral of both sides, okay? Like, I don't know if this was ever emphasized, you know, 100% last semester, but an equation like this, you're technically taking the integral of the left side and the right side kind of separately with respect to x. You know what I mean? And so we can get dx over here, and now when we take the integral of both sides with respect to x, the integral of dy, well, I take it back. You'll be taking the integral of the left side with respect to y. So the integral of dy, that's what that means, dy with respect to y. So integral of dy with respect to y, right? That was, again, sorry, that's repetitive to say that again. Such an easy mistake to make. So the integral of dy is just y, and the integral of 2x plus 4 with respect to x, as you know, is x squared plus 4x plus c. So just a quick recap, because that wasn't the smoothest of rides there. So you're given an equation, you know, with dy dx in it, and you want to, take it back to figuring out all the functions y that satisfy it. So you would kind of like move the dx to the other side and then integrate both sides. And the integral of basically 1 with respect to y is y, and the integral of 2x plus 4 with respect to x is x squared plus 4x plus c. Okay? Plus c. Now, technically, there would be a plus c also on the left side, but if this was just y plus some constant, and this was x squared plus 4x plus some constant, couldn't we just like combine the constants wherever, and I guess that's over here on the right side. And so we really just need 1 plus c, and that is all the functions that satisfy it. So basically, as you know from last semester, this whole plus c business, that means there's an infinite number of solutions. This is a general solution because it could be plus 0, it could be plus 1, it could be minus 1, it could be plus negative 1, it could be a plus negative 3 or just minus 3, it could be a plus 2.5, and if you have your like a graphing calculator handy, or if you want to pop onto say like Desmos.com or whatever website or app is trending in whatever year you were in. Like I'm sitting in the year 2019 right now. Desmos.com is a pretty good option. And throw all these in, and you probably did this kind of little graphing discovery last semester, and you can see the whole like all of the general solutions. Well, said that wrong too probably. You can see all of the particular solutions for particular c values, all the different c values, but this is the general solution. This is representing all the functions. Moving on to this next example. This should also be basically like review from last semester. Find the particular solution to the equation dy dx equals 2x plus 4. So we're going to solve this differential equation, which again is the lingo, is like you're going to figure out what y equals. So you're taking dy dx and going back to y. So the first thing we're going to do is, I guess I'm taking some liberties here because, technically dx goes to the other side. Okay? And you can integrate both sides. And get this. Y equals x squared plus 4x plus c. And this would be the general solution. But if they give you extra info like this, right over here, that f of negative 1 equals 1, or in other words, oh boy, let's see my mouse skills. In other words, y equals 1 when, oh boy, so this is essentially what this is saying. When x equals 1, y will be 1. So f of negative 1 equals 1. And that's what you probably heard Mrs. Klutz say at least once or twice. It's called an initial value. And when you're given an initial value, you can take a general solution where there's a plus c and actually figure out what the particular c value would be that satisfies this extra info. So what we're going to do here is we're going to plug in negative 1 for x, and it's all supposed to equal 1 over here. So we're going to plug in 1 for y, basically. And this allows us to figure out exactly what that means for our c value. Negative 1 squared is 1, 4, yada, yada, yada. And we end up with c equals 4. So now we can rewrite our answer knowing that our c value is actually 4. And this would be, of course, what they're asking for, the particular solution. So again, quick recap. If they're asking for all functions or the general solution, you're going to end up with a plus c, and that's the best you can do from this last example. But since they give you extra info like f of negative 1 equals 1, you can actually get that particular solution with that particular c value. One more example? Yep, just one more example. Let's see if there's anything new that comes along with this. Find the particular solution to the equation dy dx equals e to the x minus 6x squared, whose graph passes through the point 1, 0. Alright, so possibly the only thing newish about this example, like why we're even doing an extra example, one more example in this lesson, is just maybe the way they present the information, like how they say whose graph passes through the point 1, 0. They're basically saying for which f of 1 equals 0, or the other translation, y equals 0 when x equals 1. Sorry, that's so sloppy. Just using my mouse to do that. But yeah, so just to show you another little way, little variation how they can give you an initial value, but you're just going to, again, same thing, move the dx to the other side, integrate both sides, this one with respect to y, this side with respect to x. Remember how the integral of e to the x is just e to the x. And the integral here is going to end up being, negative 2x cubed plus c. And now you just take that general solution like we did in the last example, plug in 0 for y, plug in 1 for x, and let's see what that means for c. E to the first is just e. Looks like we're going to leave it like that and end up with c equals 2 minus e, right? When you get c by itself. Now, you could approximate this, but it's best to leave it exact. So yeah, 2 minus e is what we're going to call c. We're not going to approximate this. And so now you can take the c value and, plug it in for the c to get your final particular solution, just like this. And that will actually do it for section 2.1. Just it's pretty much the same song and dance as you were solving equations like this technically, I'm sure, last semester. Maybe you just didn't know they were called differential equations, or I don't know, maybe it just wasn't presented exactly like that, that you were given an equation that just said dy dx equals whatever, and you were told to figure out what y equals. And anyway, again, if nothing else, review and reminding you of the difference between a general solution and a particular solution that you can figure out if they give you some kind of initial value or extra info.